good morning. After after the show, that is almost like a comedy show. It is a tough act to follow. Anyway, so part of what I've been doing in VMware for the last probably 3 years, 2.5 years, is related to how we get a product that was acquired by VMware a couple of years ago and integrate with the solutions that we design in the professional services. And as we know, there's always growing pains, as in we started with a company that is totally startup mode where documentation is scarce. Whenever you have a project, it's almost designed on the fly. You implement while you're getting along with the customer, and it's really hard to start anything from scratch. So the first project that I had on professional services with Avi was related to, okay, I asked for documentation. I got a document that literally was on the wrong color. It was an installation and design document. We spent 2 weeks creating something that it could be used. This was 2.5 years ago. Since then, we worked a lot, and now we have some documentation that we can rely on, some documentation that we can use to present to the customers. We have a slide deck with an overview of the product that I'm trying to consolidate in probably 20 slides now, but it's similar to a 70 slide deck. And pretty much what is happening is Avi slowly is crawling in and creeping in any single implementation that we do, because sooner or later we're gonna lose the NSX native load balancer, and we need to start moving the things for Avi, like it or not. It's pretty much that. So before I get started, Avi, so these are pretty much the 4 topics that I'm going to work on. So the first one is who am I and why should you listen to me? Then a bit of an overview of what is the platform and how it works. Some key use cases that people sometimes figure out that, okay, Avi is just another load balancer. It's a bit more than that. And sometimes the way that we address the customer, we need to make sure that he understands that he's just more than a load balancer and it can really help doing their work. And then I'm going to use 2 examples of 2 customer implementations that are a bit out of the norm in terms of how we do stuff or how we do projects and how we deploy Avi. But starting, who am I? So my name is Ricardo Adao. I work in the professional services team in VMware UK. My area of focus is NSX. However, about 2.5 years ago, one thing that started is I don't want to do this, slowly got my attention, which is from the first Avi project, there was a bad experience. I was like, this is bad. I don't want it. But slowly, I got a bit more passionate about it. And in fact, I spend, I would say, almost a day per week getting up to speed with what happened on the week before in terms of development. Because Avi is still growing quickly and really fast in terms of development cycles. So we need to catch up quite often with the technology. So I am Portuguese. So these are some pictures from the things that I normally use. So this is one from Lisbon, where I was born. Another one from Lisbon. Pastéis de nata, so custard starts for some of you that like it. 100-foot wave, so on the last couple of years, there was a bit of more reference to Portugal related to the surfing of big waves, which is on the Nazaré, which is close to my wife's village. But also, this picture is from a documentary from HBO. If you guys like to see something related to the sea and big waves, etc., nice to see. Is a place to see it. This is a map of typically of the food and the traditional foods that we have around the country. If you look at it more closely, there is no chicken there. So there is no Nando's. Nando's is South African. Yes, he has Mozambican origins, but no, Nando's is not Portuguese at all. They kind of pick up some of our things and basically look like Portuguese, but in the end of the day, they are not. They don't even play Portuguese music on the restaurants, so it's all Brazilian. But the food is good, so place to go if you want like food from seafood to meat or vegetarian. Portugal you can find, and you can basically pick your poison, so to speak. And then there was another map that I had there, but I thought that it was a bit out of the question, which it was related to the wine and the regions of wine in Portugal. So for people that don't know, Portugal is one of the biggest producers of wine in the world, but we consume majority of it. That is why we don't export a lot. So, but it's pretty much one of the reasons why the Portuguese wine is not as well known as the French, because we are a small country. We are one of the top producers of the 10 in the world, but we still consume a lot of internally the wine. So majority of the wine that come out is either through Waitroses or through Tesco's. There is some bits and bobs that comes out of the other vendors, but it's pretty much the wine is one of the things that I normally and I enjoy. Okay, so I'm a really big motorsports fan. I don't really care if it is a lawnmower or for F1. I'm gonna race it if you allow me to do it. I have 2 clubs. Majority of it is sporting, so if there is any Arsenal fans, sorry about it. But is the club where Ronaldo was discovered, and it's pretty much my club because I was an athlete there for 30 years doing gymnastics. And then the Green Bay Packers, so NFL fan, and typically I was a bit concerned that if the draft was tonight, I probably was not like quite awake today. But hey, it's only today. And then my 2 passions, so gymnastics. I did gymnastics for 30 years, from 6 to 36. I stopped when I moved to UK. And then surfing, every time that I can is where you're gonna find me. So all my holidays in Portugal are literally, I pick up the surfboard, cross the street, go to the beach, and get on the end of the day. And then my big passion, my kid is turned 4 now, is becoming a little brat, to not say anything. So he's cheeky as hell, he's becoming bilingual, and which is funny because people sometimes assume that 2 languages will difficult their heads. It's amazing what they can do with 2 languages and what they develop in terms of, because they know 2 languages, they are developing some skills of translation. They are able to identify, they are able to ignore us when they don't want us to, he does not want to follow us. He fully understands Portuguese, but sometimes he has selective audition. But I think that we are like that. Okay, so, okay. The next couple of slides is a bit of an overview of why AVI is different and what we can get from AVI and why is different from a traditional F5, a traditional Nginx ADC, or any other technology that does load balancing and application delivery. So it is a pure software-based architecture. Everything can be deployed by API, is all programmatically. There is no hardware. You can decide to not even use bare metal servers if you want. You can use VMs. It does not matter even if it is a virtual machine in VMware, virtual machine in AWS. It does not really care. It's all API driven. Whatever you can do on the UI, you can do on the API. And typically, what you can do on the API, sometimes you cannot do on the UI. And the reason is because the UI is lagging in terms of the feature sets that you are developing. So that is one of the gaps that developers are still trying to match, to basically pick up. Then all the infrastructure can be automated. So you can use all the AWS features and to deploy these as a, just go to the Amazon Marketplace, buy the application and use it. And the analytics and reporting is probably one of the things that AVI has that is completely different from the other technologies. The amount of data points and the amount of data that you can grab from the monitoring of the application itself allows you to optimize your own application. We had customers where the logging and the facility that is available to them through the UI allow them to identify issues on simple things as the sizes of the payloads, the information that was going within the payloads of the HTTP, or anything that you can identify. And then it can be dynamic auto-scaling. So, for example, one of the challenges that you have with Nginx, F5s, Citrix, and Netscaler is if you need more power, you need another chassis. You need to wait for the entire sales cycle of getting a new chassis, getting more, or a bigger chassis, or a more capable chassis. In Avi, because it's easy to scale, you can just deploy another VM, another container, something that's going to do more work for you. A bit of overview of the architecture. So the architecture is divided as similar to how NSX is. You have the control plane that is totally isolated from the data plane. You have then the data plane can be bare metal servers, can be virtualized in VMs, KVMs, does not really matter. You can also use the container solution where you can use Avi containerized solution. But then it does not matter if it is on-premise or public cloud, which one of the things that is a big advantage is if you set up something on the on-premises, for example, on a VM solution with Avi, you can use exactly the same set of configurations in AWS. Of course, we have some differences from the infrastructure overlay or the infrastructure layer. However, the setup of the services are exactly the same. So you have a central orchestration platform, which is in the controller plane. The elasticity allows you to grow as much as you want in terms of either scaling vertically or scaling horizontally your capacity of load balancer. The resiliency in case of failure of a data plane element, you're going to have another that's going to be either spin up if you can, or it's going to be passed the work to other ones that are in standby. The analytics and the automation is all part of UI that can increase or decrease or force a scale out, or there is methodologies to do that on demand. So for example, if you reach to a point where your load balancers get to 80% of CPU cycles in use, you can trigger an event that will scale the solution to allow to cope with the extra work. The same way that once it gets down, you can basically scale in stuff. Then you have the ALB, the NSX ALB Pulse, which is a cloud solution where you're going to get the signatures of the new attacks for the WAF solutions, for recognizing bad IPs in case of the reputation of IPs. So you have all those things that you need, that it can be centralized and taken from some of the VMware repositories. So there is a convergence of some of these things to be basically brought into the same sources to make sure that we have a single point where the things change. In terms of product capability, you have the software-defined platform, which allows you to do all the things that you expect from a software-defined. So you can programmatically do everything, or you can just rely on the UI. It all depends on what you can do or how you want to use it. Then in terms of application services, you have traditional SLB, so the logical load balancer, daily they use. You have the GSLB, the global traffic management, where you can create solutions active-active, where based on the policies that you define, you can say, if someone comes from UK, use this data center. If someone comes from Portugal, use somewhere that is, for example, close to Portugal. So the same way that you can use source IPs, you can use multiple policies and multiple reasons for going through one side or the other side. App security in WAF, you have a layer 7 capability of blocking traffic and inspecting what the traffic is happening based on behaviors. The container ingress services is, for example, if you have a TKG solution or a Kubernetes pure solution or OpenShift or something that basically uses a containerized solution, you are able to use Avi as an ingress controller. instead of using the built-in solutions or anything that comes in. There is some restrictions and there is some kind of limitations of what you can do, but some of them are related to the orchestrated component from the, for example, the Tanzu side, which as you know, there is 2 versions. But it depends if you use the upstream version that comes from the open source community or if you use the VMware TKG version. So all of these goes through the analytics and the observability part of the solution, which it can allow you to analyze what users use the application, what users use your services. You can use the solution to authenticate all the requests based, for example, in the SAML, or when you have a single sign-on authentication and you have an application that goes through. And then you have on the back of it, more than the log analytics, you also have, based on the behavior of some applications, you can take actions. For example, if you suspect that a behavior is not valid, you can trace that back and try to block that out and create rules to do that. So in terms of components, we already said that we have the control plane. Then on the control plane, you have 2 options. You either have a standalone controller, which typically we use in the labs, but then you have normally a 3-node controller. It works as in the same way as the NSX manager. You have a zookeeper methodology, so you need 2 to do something. With 1, you have the same limitations that you have in NSX manager. But typically, the 3 of them work together, and they in a production solution, you don't want to use a standalone because you don't want to rely in a single point of failure. In the data plane, you have what we call the service engines, which is where the load balancing work and all the application work is done. So the control plane does not have any customer traffic at all. It's just, as the NSX manager, it's just there for you to either use the UI, use the APIs, or manage the solution. Once the service engines are created, they connect back to the NSX controller the same way that the edges do. And then after that is when they get some information and receive the data to move forward. So when you spin up a new service engine, so a new load balancer, that load balancer does not have a clue what's going to do. It literally needs to wait until it's being instructed of what virtual services you're going to host, what things you're going to do. So the service engine is a Linux VM with a bare minimum thing without anything until the controller instructs what you want to do. The client speaks with the service engines, so there is no interaction with the controller from the client point of view in terms of applications. So in AVI or NSXLB, I'm gonna literally interchange between the 2 names because it's still sort of a confusion of what name is going to prevail. So I'm gonna interchange between them. But there is a concept of a cloud construct within AVI, and that is not more than just agglomeration of configuration. So it does not have any relation to the cloud that you are using. It's just how you agglomerate the configuration. That cloud can be an NSXT cloud, which literally use NSXT and a vCenter, but it can be a vCenter cloud, which uses only the vCenter information. It can be a AWS, which interacts with the AWS, or literally it will depend on what orchestrator you're going to use. This is all API driven. So the controller speaks with the orchestrators. In case of the NSXT cloud, for example, it takes the networking information from the NSXT, but when it needs to provision load balancers, it connects to the vCenter and speaks with the vCenter. So simple things as, if you need to use NSXT cloud and you expect the vCenter port groups that you create on your distributed switch appear on AVI controller, it will not appear if you are using NSXT cloud because the networking information comes from the NSXT itself. You have 2 big types. You have the write access cloud. So if you have access to orchestrator that can provision the service engines, you can literally take care of all this life cycle of the service engine. So you can spin up a service engine, you can kill the service engine, you can resize the service engine, you can do multiple things. You can connect them to multiple networks, you can do whatever you want through the controller. So you don't need to go to the vCenter and just say, look, this NIC needs to be connected to this port group. You don't need to handle that. And then you have the no-access cloud. So the no-access cloud is in the cases where you don't have control of your infrastructure, or when you don't have control of your orchestrator that takes care of the service engines. Simple example, if you have a vCenter that you can interact with it, but you cannot provision VMs, you probably need to use an no-access cloud, because what's going to happen is someone's going to provision the service engines for you, and then connect back to the controller, and then you handle everything from there. The same way that in the AWS cloud, for example, is also one example where you provision the VMs there, but it's not your controller that actively provisioning the things. It just configures the AWS service engines. One thing that is sometimes misconceived is that the no-access cloud is a bit of limited what you can do, but in some occasions, it's literally way more flexible that we can imagine. So one of the examples that I'm going to use is from a customer that we are using this, we implemented this platform on top of, just for a chance, a vCenter and VMware stuff. But because of some limitations that they had, we could not use neither the NSXT or the vCenter integration. We needed to use the no-access cloud. And what happened is, because we're using that no-access cloud, we literally open to all the features that we could use, and we end up with a solution where we provision and we deal with the lifecycle of everything through Ansible, as in they pick up their configuration from the GitHub, change things, push it to the Avi. Avi spins up, takes care of everything, and then in the end, you have something that you are fully managed through the automation without even going to the UI majority of the times. So this was one of the solutions that it was result of limitations of the infrastructure. And that is why sometimes when we go to the customers with the Avi solution, we try to, before we define which cloud or which configuration we're going to do, is understand, okay, what is really stopping you, or what is a problem that it can stop you from using something or other cloud, or what are the limitations of using one or the other. So in the data plane, you have sort of 2/3 modes in terms of the high availability modes. And this is one major difference from a lot of the application delivery controllers, so the traditional load balancers. So a traditional load balancer fits on this category, where you have an active standby solution, where you have one of them, or the active typically, owning the request for the VIP addresses or for the services, and then it will only work by itself. And the other one's going to be in standby, taking care of having the connections, taking care of having the sessions. In case of the first one fail, you're going to use the second one. In Avi, you have the elastic HA, as we call, and then you have the other methodology, which is you start, instead of having one serving your request, you have multiple instances serving your requests, even for the same VIP address. And then you have two methodologies there, which is the active-active is more on the solutions in production that you don't really have a problem with the licensing itself, where you kind of don't care if you go fast in terms of the scaling horizontally of the number of the licenses that you consume, instead of just consolidating everything in a small number of licenses. The main difference is, for example, on active-active elastic HA, when you deploy a virtual service, it will be installed into service engines as a minimum. So it means that any virtual services that we install, you're going to use two, independent of what the size of the service engine group to. On the elastic HA N+M, the idea is you have an n amount of capacity, but then that m defines out of the service engine group and the size that you have, how many capacity you have reserved in case of a failure. For example, if it is 3 plus 1, what happens is you have 3 service engines deployed, but then when you are placing the VSs, you are guaranteeing that on the 3 slots that you have on each service engine, you have the capacity of 1 service engine. So it's almost, it works almost like the HA slots on the vSphere traditional world, where you guarantee that you're going to have these amounts free before you take any action. This slider is literally on the least efficient is in terms of licensing, for example. You have, on the legacy solution, you have an active standby. You typically are burning half of the licenses because you have one that is listening, the other one is in standby. So even if you distribute the virtual services across the 2 and have active standby, like active standby in A for VS1, active standby in B for VS2, you still are burning licenses because you cannot grow past that, and typically you need to grow vertically and give more power to the service engine. So this is typically a solution when you need to migrate from traditional load balancing with least impact of what you are doing, or if you are migrating, for example, from V to NSXT, and then you need to use the basic license, which is the basic license is a way of giving a facility to use load balancing on an NSX solution without losing, when you lose the NSX native load balancer, already preparing you to move to NSX load balancer later with the enterprise solution. Then you have, on the other extreme, the elastic N plus M, which is you are creating a bunch of service engines that you probably have a bunch of them empty, because the way that by default the N plus M works is it tries to consolidate the VSs on the minimum number of service engines. Okay. So the data plane scaling, we were talking about legacy versus elastic HA. So when you have the traditional legacy, or typically on the traditional ADC solutions, if you have a solution with a load balancer with 2 CPUs, for example, and you need to grow, you need to increase the number of CPUs to give you more capacity. Sometimes that is not real. For example, if you do these on the NSXV load balancer, it does not mean that you're going to get more performance, because in the end of the day, the load balancer in NSXV is a single-threaded load balancer, so you are not taking advantage of the extra CPUs. However, but you are shifting the work for the rest of the things that the ESGs, for example, are doing to give power to the load balancer itself. So this is if you want to scale vertically, as in you are scaling up the size of the service engines. On AVI, typically you do that when you need to accommodate more SSL throughput, more SSL offload, for example. You need CPU power. Or if you have WAF capability installed on the solution, you need cores to deal with the AF part of the solution. With AVI, you have on the elastic HA the capability of, you start with 2 CPUs, so you have a small load balancer. If you need more capacity, instead of growing up, you just create one more, and then you have multiple smaller working to keep up with the work. Which means also, for example, if you have one of the cores that is being pegged because of a feature that is related to the load balancer, for example, the WAF, you have creating a bottleneck there. By creating multiple service engines, you are shifting and basically spreading that pain through the entire service engine group instead of the service engine itself. So the number of service engines that you can have on a service engine group will be limited to the number of the maximum number that you configure in a service engine group. We were talking about active solutions. So on active solutions, how can you, in a traditional manner, when you have 2 load balancers with active standby, you have the ARP to kind of listen to the VIP address, and then that one responds to that ARP, and then he sticks a session there, and he keeps working that way, and only that one responds. Okay, so how can we move that from that only kind of networking bound solution to, okay, now we have two, and we need to deal with the two requests. So if you have two service engines responding to the same VIP address, how does it work? There is two ways of working that. So you have the native scaling. So the native scaling is a more limited solution because the way it works, it kind of uses some tweaks on the networking stack of the service engine to allow the service engine to respond as if it was the original service engine. So in here you have the VMs, you have one service engine, you have your client. So your client speaks with the service engine, so in case of a single service engine. Client speaks with the service engine makes a request to the VM, which is serving your application. It goes back, everything goes, okay? Let's say that suddenly the amount of requests grow to a level that your service engine alone cannot cope with it. So you deploy more service engines, and what happens is this service engine 1 becomes the primary service engine, and the primary service engine is the only one out of the group that responds to the ARP. So it means that the initial request comes to the primary. The primary sees, okay, can I handle it? If I cannot handle it, I'm going to pass to one of the other ones, and then the other one passes the request to the VM on the back. And then on the way out, what happens is the service engine responds directly to the client as if he had the VIP. So what happened is the MAC address of the packet that goes out goes with the MAC address of the service engine that basically is responding back. The subsequent connections will still go through the primary if it's not part of the same session. So what it does is the primary intercepts the first one, and if it cannot handle it, it passes the information to the other one to basically cope with it and deal with that, and then it will deal with that until the end of the life cycle of that connection. There is one way, for example, of forcing the way back through the same service engine with the tunnel mode. However, that means that you then are limited by what this one can process, right? Which is a problem because when this is having a primary function, you are already saying that, okay, this guy is not 100% a load balancer. He has a second task of doing the dispatcher of the work to the other ones. So you are losing performance. So out of a service engine group, for example, with 4, which is the maximum with the native scaling, you are saying that you have 100% of service engine capability on the remaining 3, but the first one is already paying a price of losing time doing the work. So it's literally, you cannot count this one as 100% utilization for the load balancing. You will do, for example, worst case scenario, 25%. Because if this is heavily hit, you could take 75% of the capability of him to do load balancing work. So it means that instead of having, for example, 4 times 100% capability, you have 3 times 100% plus 125. The second way of doing it is using the ECMP. The ECMP is a bit more a networking traditional way of dealing with work, the same way that we do with the ESGs in NSXT, or the edges in NSXT, where you kind of make multiple parts to the solution, and then you can use them to increase the throughput. So in an ECMP scaling, you still have initially a service engine, then you have, the main difference is you have a router in the middle. So what happens is your connection goes through a routing device. Could it be a T1, could be a BGP router, could be anything that does dynamic routing, and even static routing. The problem with the static routing is you don't have a way of pulling the routes in case of a failover service engine. But typically, you either use BGP, or in case of NSXT, the controller injects static routes on demand on the T1. So in this situation, what happens is your client goes to the router that basically knows, okay, my VIP is behind my service engine, so is has in the router information that says the next op for my VIP address is my service engine. So the service engine has its own IP, and we are doing a routing to the service engine. Then goes back to the service engine, goes exactly as normal. If the work increases and we need to deploy more service engines, what happens is either with BGP or NSXT, these router in front going to have multiple routes and say, my VIP address is behind these, and these. So it means that you have now 3 paths, and you are based on the hash of the ECMP algorithm to, well, in the hash algorithm of the ECMP to spread the work across the 3 service engines. And then means that each service engine is working individually. There is, the sessions are maintained between them, for example, because when you have a failure of a service engine, you have a situation where you lost one route, but you still have traffic in flight that you need to rebalance. At that point, the service engines, because they have the information about what is on the other service engines, and because the hashing will redistribute the things, you will keep the session going, except if you have the DFW in place. Oh, only 2 minutes. So, okay. Okay, so key use cases. We know that it's only a simple load balancer, but in fact, if we look at the use cases where we should or we can use Avi, is more than that. Is if we have a data center automation situation where we don't want to deal with the provisioning or load balancing manually, we can automate everything. We literally can spin up, spin down VMs. We can do whatever we want on the load balancers. Multi-cloud consistency is what we spoke already. Is like, if you configure that for on-premises, the configuration is probably going to be the same for AWS solution or something like that, because the virtual services point of view is exactly the same. Visibility troubleshooting, the amount of data points that you get and the amount of data that you have, it will allow you to optimize your applications. So we had customers where only by looking at the way or the logs on the analytics and the response times from the servers, we figured out that there were servers that were behaving badly in terms of the way that they were processing the data, and they were able to grow, for example, the server pool, or they were able to change their application to optimize that. So this is probably one of the things that people remember the least on our point of view when we are doing networking only, but the application people, when they have access to these, they basically get like completely nuts and trying to optimize their applications. Okay, so I'm just going to go through one of the use cases for that is different from the rest. So we had a customer that came to us, and they had a traditional F5 infrastructure. They have big chassis of F5s with blades and with partitions and virtual F5s. So it was like a massive amount of things. And one of the things that they were struggling is the automation of that. They couldn't scale as quick as they wanted. They couldn't basically say, okay, I have an event this week. I just want this brutal performance for these events. They couldn't do that because they were inflexible the way that they could manage their F5s, and it was hard to code against their F5s. So these started as a F5 migration to Avi. The initial state for them was that they had multiple zones where they had an external shared, where it was the external services that were shared across the multiple companies that they had. Then have the 2 web servers that one of them was based on Kubernetes, the other one was traditional servers. And on the web side of things, they had a second load balance layer only for the SSL. So this was an interesting one, because they had F5s on the front and they have these load balancers on the back that they were doing only SSL, because they were able to do way more work on those load balancers on the F5 allows it. And then they have the internal part where they have their services, their load balancing, and then they had, again, the application side of it. So traditional two-layer in some of the cases were the internal applications. When we moved everything to Avi, we end up with a solution that, okay, we basically redone the way that they were handled that, and what happened is we had, for example, we were sharing some of the service engine groups to allow us to optimize the resources. So we created 3 sections. So we created one section for their shared work, one zone for the web part of the things, and then they had one area only for the backend applications. And this was done this way because by having bigger service engine groups, they were able to utilize the license better and also shift the workloads based on what they needed. So instead of, for example, having 4 for this one, 4 for this one, they had, let's say, 8 for this one, and they were shifting and scaling the virtual services as they needed. For example, if they needed more work or more power for some of the services here, they were scaling the service, and because the service engine group was bigger, they allowed them to grow bigger than if they had a smaller one. So they were shifting kind of the needs of the resourcing based on the current needs instead of just having a bunch of chassis or a bunch of VMs not doing anything. A quick overview. So this was deployed through 3 sites. They have 3 sites: production, DR, and test. Then it was around 950 virtual services, which and these 950 virtual services was only the F5s. There is a second stage of the project where we're going to migrate these ones also to Avi. And then out of the entire F5s, we migrated close to 150, 160 iRules. So a lot of the work was, they had iRules in F5 that some of them were not relevant anymore, or they needed to basically be redone and rewritten. Amazingly, this was an orchestration solution, and this was because they have this platform, which is a VMware platform, but connected to ACI using Cisco ACI with VMM. So the VMM, the virtual machine manager, has a challenge, which is when it creates a port group, it creates a port group with a tag. So it literally is, I think it's VGT. I don't remember anymore which one it is, but the packets within the port group are tagged, which means that the only way that we could do that in the service engines was by using sub-interfaces on the solution. The problem is neither NSX Cloud, vCenter Cloud is able to do sub-interfaces on the service engines yet. So we need to go that route because of that, but also because they wanted to leverage their internal development team to use Ansible to do all of these. So all the life cycle of this solution, so from the BGP configuration to the ECMP to the service engines, because we end up running BGP between the service engines and the routers in front of the solution, is all automated. So once we migrated things, the first thing that they did is they picked up all the configuration, they changed it and created unique IDs to identify the objects uniquely, dump it again on GitHub, check what they needed to do, get it back again, and re-provision everything in one go, only by using the APIs. The use of the UI for them was almost to allow them to get in and check what the performance of the things were. We were using shared groups with tenants, which is something that we cannot do, for example, with neither of an NSX or vCenter Cloud. So we were creating big pools of service engines to allow them to use the licensing as they needed, and not they didn't have licenses that were there just sitting around and doing anything. So SE lifecycle, VS lifecycle, the scaling of the thing. So I remember that they had a big event in the end of last year, on November, that they grown the solution that supported that to a decent size for the workload that they needed, 2 weeks later, they didn't need it anymore. They scaled down the solution and scaled up the next one because they were able to do that in a programmatically fashion. They were taking, so this customer had the challenge for us as VMware. They were interested of getting real-time metrics with 5 seconds granularity. These represents a challenge for the controllers to make sure that it gets all the data consolidated and ready to be consumed by Prometheus, for example, in 5 seconds. So we basically go on back to engineering and try to understand and make POCs, et cetera, to understand, okay, how much can we do it? And we end up that if they basically they put the 950 virtual services all with real metrics and take 5 seconds out of them, even basically only by querying every 30 seconds, they would not be able to, the controllers would not be able to cope with it because the time that they needed to process was bigger than the sample that you were taking. So we need to go back and redo these all. One of the things that they used that was quite cool is they gave the tenants or the multiple teams access to their virtual services. So they were able to check the performance of their own virtual services based on the Active Directory group. So when you log in, the active group or the Active Directory group was identified, and by the name of the active group, you got the role that will have access to certain virtual services only. So for someone that knows Avi, for example, you know that you have that RBAC part of the solution where you can give key values. So what happened is we were filtering based on the key values to allow them to only see whatever. So 2 users connected to the same tenant, for example, they were not able to see what they didn't have rights to see. Okay, so these was Kubernetes and traditional workload. So that was not only virtual machines based workload. Okay, so we don't have time for this one. No, it's fine, it's fine. So this one is just a Tanzu solution with GSLB where we have NSX Load Balancer and Avi Load Balancer for ingress. And then we have the GSLB on top of it doing GSLB for both. Okay, so this is pretty much some key information about myself. So my Twitter handle, LinkedIn, and my Dodgy blog. Thank you.